So we established in the first part of the history lesson that computing is really just all about ones and noughts. So in this first part of the history, we're going to start way back in the 19th century, where people started to work out that machines controlled with ones and noughts really could be quite useful. But let's start with someone who laid the absolute theoretical foundations for computing. This isn't a computer scientist at all, this is a mathematician. His name's George Boole. He lived in about the 1830s, 1840s. He died in 1864. He's famous for inventing something called Boolean algebra, sometimes called Boolean logic. And although obviously no one realised it at the time, in hindsight he's regarded as one of the absolute founding fathers of computer science. Boole's insight was to realise that you could have a form of mathematics where there were just two quantities. And he defined logic as a mathematics where there were just two quantities involved, those quantities being true and false. And we've met previously that true, false, one, naught, on, off are the fundamental ideas behind computing. Let's just see the sort of rules that Boole came up with a long time ago. So A is a true statement, B is a true statement, C is a false statement. They can be anything you like. And Boole's insight simply is that you can combine these values in something that looks a bit like mathematics. So we can say A and B is true, because both A and B are true, so the statement A and B is also true. A and C, on the other hand, is a false statement, because C is false, so the pair together must be false. A or C is true, because A is true, and it doesn't really matter what C is. And not A is false because A is true, so not A is a false statement. And those rules like it, are in fact what's going on inside the computer that you're using at the moment. The processing unit inside all the programs you've written are based around fundamental rules like that, combining values, combining voltages, combining trues, falses, yeses and nos. Let's move on now to someone who actually built a machine. We've actually seen the machine before. This is a chap called Joseph Jacquard, who you might guess from the name was French. He was actually around a little bit before Boole. He was born in the 1750s and died in 1834. His big innovation was to work out he could control the looms in his weaving mill using a kind of punched card apparatus. It looked a bit like this. This is actually an example in the Manchester Science Museum across the other side of the Pennines. The idea is quite simple. There's a roll of cards. You can see it just there on the side of the machine there's a roll of card, and it's got holes in it. And each hole on that roll of card corresponds to a stitch. Each row of holes corresponds to a row in the printed design. So using a loom like this, Jacquard's weavers were able to produce lots of very complicated, very highly patterned fabric, and more importantly, very reliably, the pattern was all the same. It's actually been suggested that Jacquard's cards there were the first case of software theft, because rival weavers tried to steal his patterns, his rolls of punched cards, so they could produce the same patterns on their looms. Whether that's true or not, who knows? Now, let's look at a bloke who's genuinely regarded as the father of computing. This is Charles Babbage, who most people in computing would regard as the father or the grandfather of the discipline. He was born in 1791 and he started his work in about the 1820s. Now, at the time, there were things called computers in Babbage's world. The things called computers were human beings programmed by large organisations to just do arithmetic. They computed, so they were called computers. The problem with this is obviously they were doing some mind-numbingly tedious tasks, repetitive calculations over and over again, and they got things wrong. So things like books and mathematical tables in Babbage's day, which were quite important for calculating where ships were and things like that, were full of errors. So Babbage hit on the idea that what you could do was build a machine to do these calculations, and that machine obviously has quite a lot in common with the sort of things we call computers today. The first machine he built was something called a difference engine, and this is what it looked like. Well, actually it didn't look like that at all, because it was never built in Babbage's day. That's a modern replica in the Science Museum in London. Babbage had a very difficult time getting funding from the government, or perhaps more accurately using the funding in the right way. This particular machine has got many moving parts, all of which had to be made to really very very exacting tolerances, and it was generally thought at the time that it would never work, although the Science Museum, who reproduced it using tolerances achievable in Babbage's day, did actually prove that it would have worked for him. It's got 25,000 moving parts, which is quite a lot. It weighed 15 tonnes, and as you can probably work out from that picture, it's about 8 feet tall, so this isn't going to actually fit in your pocket and work as a calculator. One reason perhaps why Babbage never finished it is because he started to have ideas for a much better machine. It was something he called the analytical engine. The major difference between the difference engine and the analytical engine is that the analytical engine was going to be programmed so you could do different tasks with it. It was going to be, in fact, the world's first programmable computer, which is why Babbage is regarded as the first person who thought of the idea of a programmable computer. That's a computer you can program to do lots and lots of different tasks, just again, like the computer you're using. So everyone at the time thought Babbage was maybe a little bit ahead of his time or a little bit off his head. Amongst other famous devices he invented was a device for walking on water, which didn't work, and a device for attaching to the front of railway locomotives to bounce cows out of the way, which did work. One person who did realise that Babbage was onto something, that his ideas were possible, is this lady here. And this actually, we should pause to note, is one of the very few women that's going to be in our story for reasons that no one really understands. This is Ada Lovelace, or sometimes called Ada Byron, sometimes called Ada King. To give her her full title, Ada Byron King, Countess of Lovelace. She was the daughter of a famous poet, Lord Byron, and you've probably heard of Lord Byron and learned that he was quite an unconventional sort of chap. And she had an unconventional upbringing for a Victorian woman, not least because she was brought up and educated in science and mathematics. She lived in the early 19th century, 1815 to 1852. She died sadly very young. But one thing she read about was Babbage's work on his analytical engine. And she wrote a description of that to try to make it accessible to more people. And most importantly, or most famously, she wrote a description of a way for calculating something called the Bernoulli numbers using Babbage's analytical engine. So she's generally regarded as the first person ever to write a computer program. She wrote how the analytical engine could be programmed. These days, Ada, who is, as we said, one of the very few women in this story, is a bit of an icon for women working in computing. There are prizes named after her. There's been a programming language named after her. And if you've got an old Microsoft software authenticity hologram, there's a picture of Ada on that, proving that Windows software is authentic. Our last person is a German chap. Well, actually German, emigrated to America. He's living around about the 1880s, 1890s. He died in 1929. This is Hermann Hollerith, regarded as one of the people that produced the first calculating machine that could be used for a serious, proper task. The problem he had was he worked in the US Census Office, and the United States was taking a census every 10 years, and the problem was starting to happen that the censuses were taking longer than 10 years to count. So the 1880 census took them 8 years to count, for example, and as more and more people were emigrating to the States, there was obviously the very real possibility that the 1890 census would take significantly longer than 10 years to count, at which point there's not much point having a census in the first place. So what Hollerith did was built a machine, a tabulating machine that used punched cards that he could use to count census data. And the statistic is the 1890 census was counted in just 1 year. A lot of what he did was based around these things. These are punched cards, which is where we'll leave his particular bit of history. Again, here's a punch card. You can see the ones and noughts. There are some holes in this card, and they are ones, and there are places where the hole hasn't been made, and they are noughts. And this bit of technology was used really up until very recently, the early 80s even. You would have had punched cards around storing your data. So that's the history of computing up until about 1910, 1920. We'll move on next to the 1940s, when obviously the Second World War started, and there's nothing like a war for pushing technological innovation, and that's exactly what happened in World War II. Development of bombs and defence systems and so on, and code breaking, led to a massive expansion in the history of computing. So move on down and we'll talk about that.